Assalamu alaikum warahmatullahi wabarakatuh. Welcome back class 7th in your online physics class. Today I have taken up a topic uniform and non-uniform motion. So what is uniform motion? Now suppose a girl moves from point A to this point and she has taken to move from this point to this point she has taken 1 second and this distance is 2 meter. Now again she is moving from this point to this and she is covering the same distance, that is 2 meter, and she is taking same time, that is 1 second. Now again she is moving from this point to this point and she is covering 2 meter in 1 second. Then again when she moves from here and here she has taken 1 second to cover 2 meters, and then again she has taken 1 second to cover 2 meters. So here you can see that the time interval is same and the distance covered by a girl is same. So we say that this motion is a uniform motion and this girl is not changing her direction. She is moving in the same direction and she is covering a same distance in equal interval of time. So this motion is known as uniform motion. So what is uniform motion? When an object or a body covers equal distance in equal interval of time without any change in direction, then its motion is said to be uniform. Next, see this one. Now suppose a girl moves from point A to this point and she has taken 2 seconds to cover this distance 3 meter. Then again she has moved from this point to this point and she has taken 2 seconds to cover a distance of 5 meters. And then she moved from this point to this point and she has taken 2 seconds to cover a distance of 4 meter. And to move from this point to this point she has taken time 2 seconds and distance 3 meter. Now here you can observe that the time interval is same but the distance covered is different. So this motion is not a uniform motion. So this motion is non-uniform motion. And now suppose if I say that a girl moves a distance of 3 meter in 2 seconds, then again she covers 3 meters but not in 2 seconds, if I say in 1 second, and then again she covers a distance of 3 meter but in 4 seconds, and then she has covered a distance of 3 meters but in 3 seconds. If I say this, then you can observe here that the distance covered is same, that is 3, 3, 3 and 3. But the time taken to cover that same distance is not the same, is different. So here the time interval is different to cover the same distance. So this motion is also a non-uniform motion. And in a non-uniform motion there is a change in the direction. But in uniform motion there is no change in the direction of motion. So a non-uniform motion is when an object or a body covers equal distances in unequal interval of time or unequal distance in equal intervals of time, or there is any change in the direction of motion. Its motion is said to be non-uniform motion. For example, when an object moving in a circular path, a bus moving on a busy road, the earth revolving around the sun, and an object falling freely are the examples of non-uniform motion. Now distance and displacement. Now suppose a man wanted to move from point A to B and he has taken this route like this, and say this distance is 50 kilometers, and another man also wanted to move from point A to B but he has taken this route. Say this route is 20 kilometers. Okay, so this distance 50 kilometers. This is the distance. And what is displacement? Displacement is the shortest distance covered. Here the shortest distance is 20 kilometer. So displacement is 20 kilometer and the distance is 50 kilometers. Second is distance. Displacement means distance plus direction. If we talk about the displacement, it means we are talking about the distance and direction. And if we talk about the distance, then we are only talking about the distance covered by any object. And displacement is the shortest path. And distance is the total path covered by any object. This is the difference between distance and displacement. So speed. What is speed? Speed of an object is the distance traveled by the object per unit time. What is speed? Speed is the distance traveled upon time taken. This is the speed. The SI unit of speed is, see, we measure distance in meters, right? And we measure time in second. Then the SI unit of speed is meter per second. How we write this? Meter per second. This is the SI unit of speed. And the other commonly used unit is kilometer per hour. If we measure the distance in kilometer and time in hours, then the unit of speed is kilometer per hour. So speed of an object is the distance travelled by the object per unit time. Now suppose here the distance covered by an object is 50 kilometers and the time taken by this object to move from this point to this point, suppose he has taken 2 hours. Then the speed, what would be the speed? Speed is the distance travelled. Here the distance travelled is 50 and time taken is 2 hours. So the speed of the man would be 25 kilometer per hour. Because here the distance is given in kilometer and time is given in hours. So the speed is 25 kilometer per hour. Now if you want to convert the speed from kilometer per hour to meter per second, then what we do, we multiply the speed with 5 from 5 by 18. When we multiply this speed by 5 by 18, this will convert it into meter per second. And if you want to convert the speed from meter per second to kilometer per hour, then we will multiply the speed with the factor 18 by 5. In uniform motion, the speed of an object is constant and the direction of motion does not change. In non-uniform motion, the speed of an object is not constant and the direction of motion changes. So when there is a non-uniform motion, it means that speed is changing. So we will find out the average speed. So what is the average speed? Average speed is total distance covered upon total time taken. This is average speed. The total distance covered by an object divided by the total time taken to cover that distance gives the average speed of the object. Next is velocity. Now what is velocity? Velocity is the distance traveled by an object per unit time in a given direction. Is called its velocity. Velocity is velocity is equals to displacement upon time taken. What is speed? Speed is distance by time, right? So distance, if we talk about distance, we don't talk about the direction, but if we talk about the displacement, we will talk about the direction also. This is distance plus direction. So what is velocity? Velocity is displacement upon time taken. So the distance traveled by an object per unit time in a given direction is called its velocity. The SI unit of velocity is meter per second. When two objects move with the same speed but in different direction, their velocities are different. Similarly, when two objects move with the same speed and in the same direction, their velocities are same. The basic difference between velocity and speed is, in velocity here is displacement and in speed here is distance. It means velocity tells the direction also, but speed does not tell the direction where in which direction the object is moving. But velocity tells us the direction of an object. Next is acceleration. Now suppose a train that is at rest. Now suppose a train is at point A and it is at rest. Now when it start moving, what happens? Its velocity increases, right? And its velocity increases till it attains a constant velocity. Say this velocity is 60 km per hour. As the next station B approaches, what happens? Its velocity gradually decreases and becomes 0 at station B. So these changes in the velocity of the train are expressed in terms of acceleration. What is acceleration? Acceleration is change in velocity. What is acceleration? Acceleration is change in velocity upon time taken. If there is change in velocity, then acceleration is produced. So the definition of acceleration is the rate of change of velocity of an object is called its acceleration, and we denote the acceleration by small a. Now what is this change in velocity? This change in velocity means final velocity minus initial velocity. Okay, so acceleration is equals to change in velocity, and this change in velocity is final velocity minus initial velocity upon time taken. And students, remember, final velocity is denoted by small v, and initial velocity is denoted by small u. So acceleration is equals to v minus u upon t, that is time taken. And the unit of acceleration, see, this is change in velocity, and the SI unit of velocity is meter per second, right? And the unit of time is second. So what does it mean? Meter per second means meter per second by s. Now we reciprocate this, m upon s into 1 upon s. So here we get m by m upon s square. It means the SI unit of acceleration is meter per second square. Clear, everyone? Next topic is acceleration due to gravity. You know that Earth attracts each and every object towards its center, right? Now suppose you have dropped any object from a certain height. Now what happens? Its velocity gradually increases, and now when the velocity is increasing, what does it mean? That velocity is changing, right? So velocity is changing, it means that acceleration is produced, right? So this acceleration is produced due to gravity of the earth, and this acceleration is called acceleration due to gravity. When any object falls from a certain height, its velocity increases. Due to this change in velocity, acceleration is produced, and this acceleration is known as acceleration due to gravity because it is produced due to gravity. So this acceleration is called acceleration due to gravity, and it is denoted by small g. Its SI unit is meter per second square, and its value is 9.8 meter per second square. So small g is equals to 9.8 meter per second square. What does it mean? It means that velocity of a freely falling object increases at the rate of 9.8 meter per second. And when the object just reaches the ground or earth's surface, its velocity is maximum. Now next topic is mass. Mass is the quantity of matter contained in an object. The mass of an object remains same. It does not change with the change in the position of the object. It is represented by the symbol small m. The SI unit of mass is kilogram. The mass of an object is represented by magnitude only. Next topic is weight. The weight of an object is the force with which the object is attracted towards the center of the earth. The weight depends on the mass of the object and acceleration due to gravity. That means weight depends on m and g. Since the weight depends on the acceleration due to gravity, and we know that this acceleration due to gravity changes from place to place, right? Therefore weight of the object also changes. Students, acceleration due to gravity decreases with height and depth. Hence weight of the object also decreases with height and depth. The acceleration due to gravity is maximum at the poles. Therefore, the weight of an object is maximum at the poles. The acceleration due to gravity is minimum at the equator. Therefore, the weight of an object at the equator is minimum. The weight is represented by W, and its formula is W is equals to mg. The SI unit of weight is Newton, and in CGS it is dyne, and 1 Newton is equals to 10 to the power 5 dyne. The weight is also measured in kilogram force and gram force. This 1 kilogram force is the weight of an object of mass 1 kilogram. Similarly, 1 gram force is the weight of an object of mass 1 gram. The weight, this 1 kgf is equals to 9.8 Newton, and 1 gram force is equals to 980 dyne. And the measurement, the weight of an object is measured by a spring balance. So this is it. Your chapter is finished. Read the whole chapter very carefully. In the next class, inshallah, we will discuss numericals. Allah Hafiz.